Hi, my name's Adam, and let's talk about the implementation plan and some of the challenges. All right, let's go. So, if you're just joining us now, this is actually part 6 of a series. If you're interested in seeing the other ones, check out the description. And even in this video, check out the description for timestamps so you can skip to sections that are more interesting to you. All right, so fin is basically a subset of C#. Don't we lose XYZ feature with C#? And I would say that because fin actually compiles to low-level C that matches your input, we can keep most of what we really love about C. Direct low-level hardware access, full control over memory, no heap or GC required if you don't want it, and speed, and simplicity too. So some of you might be asking, like, how the heck is this possible? The heap is required for most C# objects. This doesn't make sense. How does fin support C-like stack allocations? Well, let's jump into some code here. And this code might look a little verbose, but I'll show you tips on how to make it less verbose later. Okay, so here's a method which is send order, and we get a burrito count. And then next what we do is we're basically stack allocating, so memory.place an order packet. If we, might be a good time to show the equivalent generated C code over here. This is basically what this one line is doing here. It's saying, okay, stack allocate our order packet and then run a constructor on it. So like set up its fields so that they're not garbage. That's basically what this is doing here. And I'm not super tied to this language here, but we do need some way of saying, hey, fin, pop down some memory for us in the generated C. So currently I'm using the idea of mem.place because I think it kind of makes sense. Anyways, then we assign the burrito count just like we would down here, nice and straightforward, and then order.send, which just expands to this. So nothing too crazy. So yeah, no heap. To be totally clear, when you're in C# running simulations and tests, that code does use the heap, but the generated code does not. So your fin generated code, no garbage collection, no heap, no fear. Sorry, I've been doing these too long. I'm getting squirrely, guys. Okay, but having access to a garbage collector is really, really handy during simulation time. So while you're doing fin or C# tests and simulations, use that easy money, just toss it out there. Yeah, you don't have to be careful in test land. You can be developer time efficient and just play with those gigs and gigs of RAM. All right, what is that using syntax all about? What's up with this? Using order packet order. What are we doing there? Well, the using statement is part of C#, and it basically ensures that the dispose method is called on order when it goes out of scope. And now we can use this to our advantage and basically mark order as garbage memory and detect bad memory accesses during simulation. Now, again, in the generated code, no memory checks are generated. So yeah, we get max speed. Okay, there are some challenges for sure in what I'm trying to do with fin and specifically implement kind of like write low-level C code, but inside of C#. And one of them is that while C# does have the const keyword, it's not really a true equivalent at all of C's const modifier, but we can kind of add that behavior. So in C, we might want to write something like const GPIO as like the type and then GPIO. And this is actually really important for embedded systems because a lot of the time we want to store as much as we can in Flash, like configuration data, constant data in Flash instead of RAM. And yeah, there's lots of options for ways we can implement this. I haven't fully settled on one yet. Feedback and suggestions are welcome. So one quick option, which we might start with, is we can add a custom read-only attribute. So if this is meant to be const GPIO, we could add this attribute here and fin will treat this and generate code for this so that this is const. That's not bad. The downside to this though is that you can't put this attribute, like if we had an array of GPIO objects or like a linked list or some other container, you can't put an attribute in there. That's just not possible. However, we could use C# source generators to automatically create the read-only version. So you create your GPIO class, and automatically C# generates the read-only version for you. And that's just for simulation, so that our C# fin code can act like an interface with our regular C code. There's also a challenge with volatile. Same deal, it has it, but it's not the same. Or C# has it, but it's not the same. And haven't settled on the exact syntax yet, but here's some options. And this one is actually nicer than the const one. Const one is something that we're gonna have to play around with it to get right. This one I think is pretty decent. You know, we just use this volatile vol of some type wrapper. And I think this is going to work well. We have volatile data and we just say load to get a copy of it atomically. When we want to store something, we could receive the volatile data like as a pointer. So this is like volatile data, or it's a pointer to volatile data. We just call store on it. So again, we store that data atomically. Depending on how, oh yeah, this is the tricky part though. Like, depending on the size of the data here, we might need to tell Fin how to enter a critical section. Currently, I am planning to target C99. If we target later versions of C, we wouldn't have to do this. So, open to suggestions and feedback there. And we could also add the feature too that within a critical section, Fin would allow you to kind of unwrap this data and get direct access to the different fields within like that data structure. I'd like to try to keep Fin moving along, or at least using similar language as like C++ and C11 atomics and later features. Because yeah, I like C. I like C++. I don't want it to be like some wacky syntax or like totally different. I want to stay close to the good stuff, the C and C++ stuff. All right, so what about challenge XYZ? I think there are solutions to the challenges. We just really need to kick the tires and see how it goes. I don't want to spend too much more time just pontificating. I want to get people who are interested, get them thinking about it, and yeah, get going. Feedback would be nice, for sure. There is a downside to basing on C#. So yeah, we get a metric and imperial for everybody. Let's be nice. We get a huge amount of benefit from basing Fin on C#, but there are some cons. And that basically comes out as that sometimes our syntax is more verbose than C's. However, it's not that bad when you consider what Fin is actually doing for us. So here's the Fin code, just a snippet, and here's the generated C code. If you just compare character versus character, these are pretty close. But we can actually even reduce that verbosity. We can make it even more concise by using the C# var keyword. I didn't use that originally because I don't know how familiar people are with C#. But in this case, this is the same equivalent thing here. Var is easily inferred by the compiler and human readers as order packet, so it's less for us to type out. That's cool. But we could also add tooling as well, so that you just type what you normally would have typed in C, like order packet order, semicolon, and we could have the tooling auto-generate this for you, which I think would be nice. Now that said too, if Fin grows to the point where we really do want to diverge from C#, that's possible. There are tutorials online that show you how to fork C#, like the compiler, and add new syntax features. Like, it's just wild. It's really cool. What a time to be alive. Where, yeah, there's tutorials walking you through how to fork a major compiler and add new syntax to it. So we can do that. I don't want to do that because then we lose a lot of the tooling, but it's nice to know we have the option. All right, custom code fixes. So sure, Adam. Lots of talk about how C# toolability is great for C# devs, but it's not for us, right? Users, embedded users can't extend it, right? C# tools for embedded devs? Actually, it is possible for us. And a really cool example, not specifically for embedded developers, but as an example of what we could do, what's possible, there's a Rosalinator project. It's not Microsoft owned or run, and it adds 325 analyzers that will find issues, 211 refactoring suggestions, 169 suggested fixes or like error and fixes. And yeah, it's non-Microsoft done. It's a non-Microsoft project, and it's really easy to add to your project too. It's not like you install this globally to your computer. You can if you want to, but you can also just, do a couple clicks or copy paste one line into your project file, and it just comes into your project. It's super cool. And yeah, this isn't specific to the Rosalinator project. It's just the C# analyzers and code fixes. They work cross-platform. They work with your VS Code IDE, with Visual Studio IDE, with the Rider IDE. It's not like proprietary to one thing. So there's the project there if you're curious to check it out. It is really cool. And it gives me a lot of hope for our own code fixes. Now, there are a lot of tutorials and walkthroughs already on how to create our own. If you look in YouTube or just Google, I like Nick. He's a good guy. Sorry, I don't know him personally. I just enjoy his videos. Anyways, so Microsoft is putting out tutorials. Other people, well-known people, are putting out tutorials. There's written ones. If you use Visual Studio, there's quick start templates that have everything ready for you to go. It's non-trivial work, but it's also not too bad. I've written a couple. All right, the costs of Fin. Dun dun dun. Actually not that bad, in my opinion. So the workflow is a bit more complicated, although as we've seen already, it's not really that much more complicated than dual targeting already. And it would be a little bit slower if you were testing and iterating on actual hardware often. So you'd compile with Fin or transpile with Fin to C, compile with C, and then flash and test your hardware. Now, if you were like really in one of those hardware loops where you really wanted to test something with hardware, just use C for a little while. You don't have to write everything in Fin. Either do it completely in C for that low-level part, and that's fine, or just prove out the concepts with this quick little iteration here and then pop it up into Fin later if you want. One other thing that we could look at doing too, and then this actually shouldn't be that hard, is having Fin projects be able to call a C compiler. So one click of a button, we transpile, we compile, and then we flash and test. Now the other risk too is that the project might fizzle out. And we've already talked about that you'd be left with a bunch of high quality C99, so not the end of the world. If we really decided that Fin was just unviable for some point or for some reason, which I don't think is going to happen, it wouldn't be that hard to add another transpiler to Fin to migrate everything to C++, like as a migration strategy, because Fin is actually very similar to C and C++. That wouldn't be too hard to do. That said, the C# test code that would be written, or that you hypothetically have written, would need manual porting, although some people I've talked to about this already have suggested that we could potentially add that to Fin, so that if you wrote your C# test code in maybe a little bit more restricted capability set, so not using all of C# ecosystem and syntax, we could actually generate like C++ tests, so you could still dual target test with C or C++. Interesting idea. It does require using C#. It's not that bad. It is cross-platform, free and open source. There are paid tools if you want like super bonus features. And yeah, VS Code is pretty awesome. Runs on Linux, Mac. Yay! Okay, the rough plan. Right now I'm at phase 0. I've created a bunch of prototypes where I've got things working. I feel pretty confident that we can overcome the challenges, at least the challenges that I'm aware of, which I've tried to do my best on this, but you never know. Maybe someone out there is going to think of something. But that's the point of this phase here, is test the water, gather feedback. Are there things that we're going to bump into that are going to be issues? Yeah, let's get going. Phase 1 is going to be like the bare minimum, simple classes, integer conversions. C# handles integers slightly differently than C, which I think is actually a really good thing. In C, if you compare, depending on the ranking of your integer types, you might compare a signed integer with an unsigned integer, and then the signed integer then looks like it's unsigned, which is usually not what you want. With C#, if you compare a signed integer with an unsigned integer, it just promotes both to the next larger data type, which makes sense to me. And like I think it's great, but it does require a bit of work for us to make sure that our simulations in C# are valid and compile the same as what we want. Anyways, pointer references, C-style arrays, C-style strings. Then phase 2, we add a whole bunch more stuff. You can pause if you're interested. This isn't fixed in stone. And eventually, I want to start looking into more of the higher level stuff, and like maybe C++ compatibility, starting to look at more dynamic memory allocation and maybe some Rust-inspired features as well. Interop. So in the meantime, if Fin code doesn't support the feature that you're looking for right now, you can just add that part in C and C++ and link it with Fin generated code. Okay, the big question, or a big question, can I really do this? I'm pretty confident that I can. I've already done a Java to C transpiler. Statesmith already transpiles C#, or a small subset of C# to C, JavaScript, and C# as well. I think the uncertainty in this project is really like how ergonomic the language is going to end up being. How ergonomic, how nice to use is Fin going to be in the tricky areas like const. Overall, I think it's a massive ergonomic improvement, especially in test. But yeah, we need to explore it and see just how nice it is to use in the hard spots. Yeah, it's go time, baby. Let's go. And Statesmith already translates a small part of C# to C. And if you're interested in helping, provide some gentle feedback. The internet's a wild place. I'm a person. I'm trying hard to do something good for the community. Please give constructive feedback. It can be, negative, but just be cool, And then if you are interested, we don't have anything on there right now other than just like a ticket to gather interest and feedback. But if you want to see or be notified when Fin starts releasing our prototype compilers, it's easy to do on GitHub. Just click on the watch or unwatch button, select custom, and then select releases. So that way you don't have to see absolutely all activity. You can just find out when there's movement on Fin. All right. Well, if you're still interested, I say that's wonderful. Thank you very much for making it through the series. And yeah, I hope to see you on GitHub, and happy in embedded developing.